CO3, then there's less for the hydrogen ions to attach to.
So in respiratory acidosis, this is going to be increased because what we want to do is, because you're going to have more of this, all right? And in order to compensate, it's going to, this is going to be increased because it's trying to combine it to get rid of it. You know what I'm saying? So when you have this, and
For
you start
respiratory
going-
acidosis.
Yes.
Yes.
Okay. So when it's compensating, this is actually working to try to get rid of stuff, but you're going to die before that happens because the respiratory problem is going to kill you. It really matters in metabolic. So going the other way. So you talked about the alkalosis. This is going to drop that. The alkalosis because we want to keep that in the body.
Makes
That
sense.
Okay. So for metabolic, you have now, this is working. For some reason, you have an increase in this. Either because you have lost bicarbonate through GI issues. It's part of the gut. So like long-term diarrhea will get rid of this. Or because through the process of fermentation, either creating lactic acid through shock or by creating ketonic acid, you're going to have an increase in this. And as soon as you increase this guy's going to come and gobble it up, and it's going to start moving this way to breathe out. All right? So what happens is then this is low. So if you have low HCO3 for metabolic purposes, it's going to make you acidic. However, the body works very well. So the CO2 is going to work to get it out, but the body's still acidic because it's still producing ketones and all that other stuff, right? So low increased pH, increased hydrogen ions. For metabolic, is going to cause you to breathe that out. So this, when that happens, is going to cause this to drop. Low HCO3, which is going to cause you to breathe out too much CO2, which is going to cause low CO2. But you already have increased hydrogen ions, so you have low pH, so you're acidic. So if you were to do the Rome method, low pH, remember Bob?
I never saw your Rome
Okay,
method.
I didn't either.
So this is what started this entire thing. So it's respiratory, opposite, metabolic equal. So this is where it comes in with registry and teaching everything. So when you're talking respiratory, what they're measuring is pH, CO2, and HCO3. Now, we can't measure this or this in the field, but we can measure this one. So initially, what I was teaching is if you have an increased hydrogen ion, you have decreased pH, right?
Mm-hmm.
Okay. So decreased pH is acid, right?
Yep.
Increased alkalosis. So in respiratory, you have an increase in CO2 and a decrease in pH. Conversely, if you had alkalosis, you'd have a decrease in CO2, an increase in pH, right?
Mm-hmm.
Respiratory opposite. More CO2, less pH. Less CO2, more pH.
Okay.
So when you're looking at those numbers, it's going to be opposite. For metabolic, it's going to be equal. If you have a drop in pH, there's two things that are going to drop. This and potentially this, because you're going to blow it out. So you're going to have decreased CO2. They're all going to be pointing in the same way, so metabolic is equal. If one goes down, the other one's going to go down. So if you're looking at numbers, what they're going to give them in registry is you have a patient with a pH of 7.3, a cap or end tidal CO2 or PaO2 of 50 and a HCO3, depending on what the number is going to be, depending on if you're having compensation or not.
So that's acidotic.
Right. So it'd be acidotic, but if my CO2 is 50, what's the norm for CO2?
35, 45.
So what would that one be?
What's the
So you have
CO2,
731.
what's the pH?
731 and a CO2 of 50. Your CO2 low or high?
Low.
In this one.
Oh, high.
So
So that'd be
So
respiratory.
low pH and, oh, you're saying is it respiratory or metabolic?
Yeah.
Respiratory.
right. So because it's opposite, right?
That's opposite, yeah.
Now the problem ends up being when you compensate, and this is what I didn't take into account, because now they're asking about compensation. So in respiratory, we'll start with metabolic first. So there's a rule to follow. Let me get the sheet.
He's so good at this.
Yeah, it's a good concept of this.
And he's so passionate about it. This is his
I'm
life.
trying to get there.
You will. I mean, how long you been an instructor now? And how long you been actually doing it? I still don't get this shit. I've been medic for almost 30 years.
Well, the thing is and I was talking to Nick about this, they didn't teach this, when I went to medic school almost 20 years ago, this wasn't taught. This is a new thing that's taught in medic school. So I initially never learned this. That's the problem. So now I'm looking at it and I'm like, shit, I was never taught this.
Yeah, I mean, I learned this in college.
Yeah, you didn't learn this, they didn't teach you this in medic school.
No, I
Now
didn't
it's
even have to
being-
take. I didn't even have to take A&P.
Yeah, now it's being taught in medic school.
Now, I learned it in medic school. My
I didn't learn all this.
instructor was an RN.
Yeah.
So uncompensated. Let's talk metabolic acidosis. So uncompensated is going to be an abnormal pH. So in this case, in metabolic acidosis, so you have a low pH with at least one of the numbers being changed. So low pH is acid, right? So when they talk about the numbers, they're talking about blood gases. So that PaCO2 is the amount of CO2 in the blood, or the amount of HCO3 in the blood. Those are the three numbers they're looking at, right? So for metabolic, you're going to have a decreased pH and a decreased HCO3. What does the body do to compensate for that?
A low pH, so acidotic, and a low, it takes the H ions, brings it over to the H2CO3,
Uh-huh.
and then from there blows it out
Yes. Now.
to the respiratory system.
Correct. So, if you are normal capnography is 35, 40, or 35, 45, right? We know that the uncompensated, your CO2 number is going to be 35 to 45 because your body hasn't done anything yet. When you start partial compensation, for this one, you got low pH, low HCO3, what does the body do? It starts
blowing off.
breathing faster, right?
Yep.
So what's going to happen with this?
It's gonna go, we're gonna blow off more CO, right?
So you're going to have low CO2.
Yeah.
Now these are all three abnormal numbers.
This is
It's trying to
metabolic.
compensate,
Yeah.
yeah. It's trying to compensate. When it has compensated, this goes to normal. So you have it partially compensated. So in uncompensated, you have a low pH and one of these two are abnormal. Which one of these two are abnormal is going to dictate whether it's respiratory or metabolic.
Okay.
The body is then going to compensate by trying to get rid of one or the other. So metabolic is going to get rid of CO2, and as it compensates, it's going to bring the pH down to normal limits while it's compensating. All right, so how does that work with respiratory?
Ooh, I'm actually understanding this a little bit.
So decreased pH, what is that? Acid. Increased CO2, right? So this is respiratory. And then your HCO3 is 22 to 26 is the normal number. So as you get into respiratory acidosis, what is your body going to do? It's going to shift the other way. It's going to take that CO2 and water and create hydrogen ions and bicarb, which is going to increase your amount of bicarb. So you're still low pH, you're still increased CO2 because you're still having a problem, but then this number is going to be above 26 because you've just created more of it by proxy. Well, as this happens and occurs and it keeps going, eventually what should happen is this pH should become within normal limits. Why does that not happen? Because the respiratory system is going to kill them. The same reason that bleeding out, you're not going to die from lactic acidosis, you're going to die from bleeding out.
Right.
So this is a very rare situation. These people, sometimes chronic COPD patients, we're going to have a little bit of abnormalities. When they draw blood gases, they're going to see kind of where they're at compensating wise. But most of the time, you're not going to get to this point. Now, in your states of going through metabolic acidosis, and if you're ever doing it to like teach for registry, they're going to give you, these type of scenarios. pH of 7.50. You got a CO2 of 30, and you have a HCO3 of 20.
All right, so your alkaline, whatever, however you say it, your CO is low, and your HCO3 is low. So you're saying is this metabolic or respiratory?
Yeah, so which one would this be?
Low, and then high.
So this is what? You said low?
Yeah, metabolic then.
So.
Oh no, because you're blowing, metabolic, because you're blowing off, you're breathing too fast?
So this CO2 level, if it was metabolic, would be high.
Okay.
So this is a respiratory.
Oh, yeah.
Alkalosis.
It would be high because you're blowing off.
Right.
Yeah.
So respiratory alkalosis, partially compensated. So your respiratory alkalosis, your body's compensating by reabsorbing more of this in order to increase your hydrogen ions to make you more acidic. So low HCO3, if this low HCO3 if this was a metabolic patient, let's say that there's metabolic acidosis. Let's go backwards. Low underneath this, right? So metabolic equal, so low pH would also be low HCO3. Okay? If I'm compensating, what would my CO2 level be?
That would be high.
So it would be low, remember, because we're blowing too much out. But what would this number be? We're acidotic.
Okay.
So this would be low, right? So you have to figure out, the steps are, you have to figure out, is it acidotic or alkalytic? And then you have to look at these numbers. If it's acidotic.
So I guess sometimes I get mixed up. When you're breathing fast, the idea is that
You have to know why you're breathing fast.
Your CO2 is, if you're breathing fast because metabolic acidosis,
Correct.
your CO2 is going to be low.
Yeah, so
Okay.
these numbers would be correct, but this number's not.
Okay.
Because metabolic acidosis in itself, you have to be acidotic. You're never gonna breathe so much in acidosis metabolic
gonna make yourself
yes.
alkaline.
So
Okay.
the idea is you figure out the pH first. You figure out the cause of it. They may say the cause in so respiratory is going to be, and this is yeah, and that's pH and CO2, and then metabolic is going to be
Alright, so respiratory, opposite, metabolic equal. That's
Yes.
what Rome is. Respiratory, opposite, metabolic equal.
so I can throw in numbers.
Is that an actual thing or did you make that up?
No, that's the thing.
Okay. So pH is low
Yep.
and everything's low.
Right. So this
it's
is low.
metabolic. Metabolic, so that's metabolic acidosis. Right?
What type? Partially or fully compensated?
Partially,
Why?
because it's not compensated yet. It's not 7.35.
But how do you know we're compensated?
Because CO2 is low?
Yep.
That means you're breathing fast?
Yep.
Okay.
That's it.
Woo!
So.
Ooh, I passed that one!
So I got.
Alright, so pH is low,
Yes.
CO2 is high, the CHO3 is normal, so it's obviously respiratory acidosis. It's respiratory acidosis,
Uncompensated.
uncompensated.
Yep. Because this hasn't moved yet.
Right. Because normal is 22 to 26.
Yep.
And
So-
so that would be, hold on. That would be high.
So if we were to compensate for respiratory acidosis,
You would try to make more. It would
it
be
goes.
high, right?
Yes. Correct. It's not.
You'd be trying to make more to get rid of the ions.
Yeah,
So
basically, and by proxy, it's stopping it from reabsorbing, kind of. So you're trying to keep it in the blood to snatch those hydrogen ions that are a byproduct of that carbonic acid cycle.
So your bicarb level would increase in this
Yes.
situation?
Correct. So now let's. So we'll revisit this then. Now, the respiratory situation. This patient is respiratory acidosis because this is increasing. We can't get rid of it. So this is increasing and it's going to send it this way. It's going to knock it over to the other side of the court. And this is going to be the byproduct that you can't get rid of. You just can't get rid of it fast enough.
Mm-hmm.
That make sense?
Yep.
That's it?
All right, we're going to revisit it again later.
All right.
Actually, I'm going to try to teach it to
Hey.
you.
Yeah.
There you go.
That's-
I'm gonna
that's a
copy
great-
this for you.
Oh, okay.
That's
yeah,
a
I don't.
great
I mean,
one.
if I was taught this, and maybe I was. I don't remember being taught that. But I mean, it was 20 years ago.
Yeah, I honestly, I picked this up